finish off the headstock handle and the expanding mandrel by fitting it onto the steering wheel and giving it a test. This is the finished item. It looks a bit big as a handle, but being soft and padded, it's easy to hold, and also the leverage from the outside to the centre is about the same as you'd get from a ratchet spanner. The expanding part works quite well. It also gives you the ability to turn the handle when you're standing in front of the chuck, so you can actually see what's happening on the chuck side. We also see what happens if you forget this is in the back and turn the lathe on. So let's go into the workshop and see how we do it. Okay, I'm just cutting the slots from the end to the hole in the middle. This one I'm just using the hacksaw. I have milled one which is a wider slot. You could still do that with a hacksaw by fitting two blades in at the same time, so as you cut, it cuts twice the width. Now all I'm doing is sawing from the end to the hole that we drilled in on all the four sides to give us the ability to open this out and expand the outside. Then once you've sewn the slot, just use a small triangular file and take each edge off and also on the inside. Now I've just wedged the nut, the tapered nut, inside the tube, clamped it up on the outside in the vise, and I'm just going to centre drill the end of the tapered nut. Now I'm drilling the 3mm hole to the centre of the nut. Just take the bolt out just to make sure. There's a tapered nut with the 3mm hole through it, which goes into the centre. So I can take this nut out now and it's ready for the 3mm pin. Right, now we come to the assembly. So this is the steering wheel that we milled the rubber off the back face. And if you remember, if you watch the other episodes, this bore is slightly tapered. So when I machined the mandrel to fit, from this side it goes halfway and locks, but from this side it goes to full depth, so that indicates this bore slightly tapered. Now my brother made one and he's pressed his in as a press fit, but I didn't want to do that because I thought if this starts to move on the shaft, when you lock the shaft in your head, then you've lost control. So what I've done on this one, I've modified the end, and what I've done is the shaft is just below this face. I've drilled 2 holes and tapped them M5, and I've drilled and tapped a 12mm hole. I'll show you what that's for in a minute. So to go on top of that, I've made a plate. I've made this plate quite big. I was originally going to use the holes, or some of the holes in here that would bolt the plate down, but then I decided not to. But I've left it big just in case I need to do that. Now this goes in and lines up with the 2 holes each side of the bar. Then in the holes I've put 2 5mm cap heads. Now to make this job easier, you could put 2 roll pins in. If you've got a roll pin, it make it easier. You wouldn't need a counter bore. You'd have more room because you're not having to thread. So it would be just 2 roll pins going, and all that does is stop this disc twisting on the shaft. Then I put the cap heads in. Just tighten this up. And what that does, it bolts this disc to the shaft. So this is, if this turns, the disc turns with it, and you can see this, the wheel will still slip. Now if this wheel slips, all I have to do is use the holes on the back here to put a cap head straight through into the aluminium, drill and tap the aluminium from the back. There are 2 smaller holes, one opposite each other, and I could just drill them from the back, tap them, put 2 cap heads through, so that would lock the aluminium disc to the steering wheel. But I'm not going to do that yet, because if I don't need to do it, if I can get away with that, it's just a bit extra work. But the wheel starts turning on the shaft, then I can lock this disc to the wheel. So the next thing to put in is this bolt. It's a 12mm bolt with a 6mm hole through it. This one looks a bit tatty because it had some steel welding on the top of it, but it's just a standard bolt, and that should fit straight down the middle into the 12mm hole in the end of the shaft. Now I can tighten this 12mm nut up. That also clamps the plate to the expanding mandrel. That's that tightened on there. Now this 12mm bolt has a 6mm hole, or it could be 6.5 if you're using 6mm bar. If you're using threaded bar for the shaft, you can use probably a 6mm hole. I've used some 6mm bar with a 6mm thread each end. That goes through the centre into the nut. And then on this, the back here, there's a washer. You can put a nut on, or you can get some sort of hand plastic knob that you can go on there to tighten this up. So all you do to fit this to the headstock is push this into the headstock from the back and turn this nut. And what happens when you turn the nut, as I turn this nut, the taper nut going down the shaft, and what happens then is each end of this mandrel is opening out and gripping on the inside of your spindle. And you just slacken the nut off and tap the end to release. Doesn't need to be tapped hard, you're just knocking the taper nut back to release it. So let's have a look on the lathe how it works. First thing to do is make sure that the spindle is clean, which I've already done. Push the expanding mandrel in till it comes to the stop. Then on the very end, tighten up the nut that pulls taper nut into the mandrel. Doesn't need a lot of force. You can feel it gripping there. Now it's gripped. Take the spanner off. If you forget and turn the machine on, the spanner will fly. What I'm hoping to do is get something like this, which is a nut captivated in plastic, so that can screw on the end. I think the nut's not very good in that one, or even a nut in plastic that you can turn by hand. You can see now I can turn that and it will turn the chuck, and if I'm standing on this side it's easy to hold the wheel and look at whatever you're machining or making. Now if you do happen to forget that that's on there, there's no problem, you can leave the lathe running with that there. It's balanced, there's no vibration from the lathe. With that on there, you can just use it. Although it looks like it's running out, obviously the wheel is not perfectly round on modern cars. It works okay. Obviously if you put this in back gear, then the amount of force you need to turn the chuck starts to build up, and if it starts to slip it means that the mandrel that they've made can't grip onto the wall of the spindle tight enough because of all the load on the back gear. But just for positioning your chuck in the right position, or a face plate or whatever you're machining, it's a nice soft handle, and being large you can get more leverage on than you would with a ratchet spanner, and you can feel as you're cutting a thread, if you're doing tapping a hole and you just want to rotate the chuck by hand, you can do that. You can feel when the thread locks up, prevent you snapping off your tap. Now to remove it, just take your spanner, hold the wheel, rotate the nut a couple of turns, and then to disengage the taper nut, just tap the thread in, and this is loose. Put that back in, just tighten the nut up, let's grip the shaft. Let's have a look how it rotates from this side. Turn the lathe on. Although this is running up and down, it's true on the centre boss, so this is the steering wheel that's not round, because if it was out too much you'd get a lot of vibration. Oh well, that's it for today. Hope you enjoyed it. If you found it interesting, why not subscribe? And we'll see you next time on Enots Engineering.